For our next problem on final review for Chapter 2, this is the type of problem that sends most students running. This is a mixture problem. Not only is it a mixture problem, but it's a mixture problem that deals with proportions instead of percentages. So we have one bronze alloy that is 3 parts brass to 2 parts zinc. Now I want you to think of that as 3/5 and 2/5, because you add up the parts to get the denominator. You have another alloy that is 5 parts brass and 1 part zinc. Again, 5/6 and 1/6. How much of each alloy should you combine to get 40 pounds of an alloy that is 3 parts brass and 1 part zinc? Now, whenever we do a word problem, I always stress the need for variables. So I'm going to say that X is going to equal the pounds of first alloy, and that Y is going to be pounds of second alloy. Now, there are actually 3 equations we could create. We only need 2. I'm going to go with the 2 more sophisticated equations just so that you can see exactly what we're trying to do. Before I go further, I want to ask, how much desired quantity do we want? Well, our final alloy is going to be 3 parts brass and 1 part zinc, and we want 40 pounds of it. So the amount of brass is going to be 30 pounds. And that's going to come from some combination of the first alloy and the second alloy. And then the amount of zinc that we want, likewise, because it's 1/4 of our final alloy and our final amount is going to be 40 pounds, we need 10 pounds of zinc. So I want to write a brass equation. Where is our brass coming from? Well, the first alloy is 3/5 brass. So I'm going to take 3/5 of my first alloy. And then I'm going to add the amount of brass that I get from my second alloy, which is 5/6. Now 5/6 of the second alloy, which is Y. Now this is all about brass, so we want this to come out to be 30. Now let's talk about zinc. Well, our zinc equation is, where does the zinc come from? Well, here we have 2/5 of it. And for the second alloy, we are going to get, let's see, 1/6 of it, and that will get me my desired 10 pounds. Now, we first started this type of problem, and we didn't have matrix solutions. But now that we know how to solve systems of matrices, with matrices, we can solve this one relatively quickly and easily and get that X is equal to 14.2, let's go to 3 decimals, 14.286 pounds, and that Y is equal to 25.714 pounds. Now, again, notice that these both added up to 40, which is what we would like. Now, at the beginning I said that there was a third equation that you could use, and that is a very simple equation, and that's that X plus Y equals 40. Now, if you use that equation in conjunction with either one of these two, you'll get the same answer. But for the purposes of illustrating how to do a mixture problem, I used these two. So just to recap, what did we do for a mixture problem? Well, we created our variables, We identified the desired quantities. Then we wrote equations for how to achieve those desired quantities in terms of the variables that we defined. Then we solved the system of equations. Now, using your matrix RREF is a lot easier than solving by elimination or substitution, but that point is just going through the algebra. The setup is what's difficult. So, again, desired quantities, variables, that gives you your equation. So, there we are.